13. Given the three forces, find the magnitude of the resultant. So magnitude, we've talked about before, it comes from polar form. It's an easier way of thinking about this. Sorry about that. I'm trying to underline it here. Magnitude in polar form, where we have r comma theta, or how you often hear me say it, is h comma theta. And I usually would use these brackets because the calculator handles them in brackets like that. The h is the magnitude. That's what we're looking for here, or the r. That's what we're looking for. So polar form can solve this for us. So here's what I'm going to do. I'm going to add the three forces together. And so I'm going to ask myself each time is this force given here in this polar form, given like this, or is it in rectangular form, which is like x comma y, or component form? Which form is it given in? Okay, that's what we're going to be looking for every time. Is which form is it given in? Is it an x, a y, or an h, if you will? Is it horizontal, is it vertical, or is it slanted? So as I look at this first piece, this is definitely slanted. And so for the calculator's purposes, I'm going to treat all of this, though it won't end up mattering for this problem, but I'm still going to do so just for consistency's sake, as if this is the origin here. And for the calculator, every angle, when I use h and theta, is going to calculate from the positive x-axis. So when I do this 10, since it's slanted, this 10 newtons here, it's going to be polar form. And so I would have the value 10, comma, and I'm going to put the angle symbol. Now I have to figure out how many degrees this is from here. Well, since this is 53.1, what I'm going to do is I'm going to go press menu here, calculator, and I'm going to take, this makes up 180, so I'll take 180, and I'll subtract 53.1. to find out that this is exactly 126.9 degrees. And so that'll be this first vector here. Now the second vector is a horizontal piece, which means it's not an h, it's an x. So the easiest way to type in this piece is it's 10 units going left. And since it's left, you put in a negative 10 in the x spot. And since it's just an x value, you put a 0 for the y. Now, I'm going to come over here. Someone might be thinking, well, this is heading left. Why is the 10 not negative? With h, the only time we would ever put an h negative, technically there are no negative h's, but the when we would is if we need to flip the arrow around. Like, for example, if it didn't say the force was 10 newtons heading in the direction 53.1 degrees from the negative x-axis, if it rather was saying it's like a wind coming from this direction, and so we would need to draw the vector with the arrow over here, that's when we would do it negative. So with that being said, let's now go to this last one. This piece is not an x, it's not horizontal, nor is it vertical. It's slanted, so it's an h. So I'm going to have 11.3, comma, and this is 45 degrees here. So doing the same kind of math we did earlier, I'm going to take it from the positive x-axis, because that's where the calculator works from. I'm going to take 180 and subtract the 45, and we should get 135. And so our angle, and I'm going to put in a negative 135 degrees here. Now I'm putting negative because my angle is going downward here. This one, it was going up from the x-axis. The other is going down, so that's why it gets a negative. That negative is talking direction here. All right, so now we have our three vectors. What we can do is we can add them together. So I hit control bracket like that, and now we can start typing them in. So control parenthesis is where I get that bracket from, and I'll hit the book. Under the fourth window is that angle symbol. I'll do 126.9, and I always throw in the degree symbol just to make sure I don't make a simple mistake here, depending on mode of the calculator. Plus, we have another bracket of negative 10, comma 0, and then we're going to add one more bracket, or one more vector, which was 11.3, comma, hit the angle symbol, and put in negative 135 degrees. Now, the two mistakes I see most frequently is regarding the angle symbol. Someone might forget to put the angle symbol, or they forget to recalculate the angle from the positive x-axis. We need to do that. So once I press enter, I now have, this is the x value, this is the y. This means the force is basically, if I round, 24 units to the left, and not neither up or down. But I can press menu, 7 for matrix and vectors, C, which stands for vectors, and choose polar. And now this will give me the magnitude exactly. It'll do like Pythagorean theorem on those and tell me this right here is my magnitude. All right, so my magnitude here, I'll just write it down, is 23.9945, comma, the angle is 179.9844. Going to the 10,000th decimal place is what I've done here. And so rounding this, the magnitude, and I'm just going to now say it is approximately, that's what the squiggly equal sign means, 24 newtons. And I took the unit we were having there, that's what the capital N stands for. So approximately 24 newtons is our answer here for magnitude.